So now let's remind ourselves about the slope of the original function. What does it mean? Now remember, we learned this back in chapter 1 and 2 and 3 actually, that when you're talking about the slope, what you really are caring about is the change in your y is what we said, but it's really your dependent variable over the change in your independent variable. Now dependent variable for us is rate. Right back here, here's the original function. It was rate is the dependent, the y, and independent is t, time, and that was years. Right, time was years. So when we're talking about this, and the slope, by the way, was 0.63, it's really 0.63 over 1. So that means that for every 1 year, you can say 1 year, just year, for every year, the passenger bumping rate increases, or is increasing, I guess you could say increases, by 0.63, 0.63 what? It's passengers per 100,000. Per 100. I guess I could just say per 100,000, right? You got to give it its unit, and that's what it is. It's per 100,000 passengers. Now remember, this is increasing because it's positive. That's a very different story than chapter 4. Chapter 4 is talking about, oh, it's 0.63, so it's decreasing because b is between 0 and 1. Right, but this is linear. This is mt plus b right there. So you have to go back to what you know from chapters 1, 2, and 3 and say, if that number is positive, I'm increasing. If it's negative, I'm decreasing. This isn't exponential growth. That's chapter 4. Okay? And chapter 5, to be honest. All right? So there we go. Now, what about the inverse function? Well, inverse reverses time and rate, right? So what was your y variable was rate, now becomes your x variable. And then time was your independent variable, and now becomes your dependent variable, your y, if you will. Okay, so we found what it was, and this is why it was so important for us to find it. It's 1.587. It's that 1 divided by 0.63 part, that number we find in front of the r. So 1.587. Let me put this in. 1.587 over 1. Now, what does it mean? That's the tricky part. So the time is 1.587. The rate, it says the passenger bumping rate, let's put it this way, increases by 1 per 100,000. The 100,000 thing is just because that's the unit. It's not, they're not bumping one more passenger, they're bumping one more per 100,000, which is sort of like bumping a passenger a day or something like that. So the passenger bumping rate increases by 1 per 100,000 every 1.587 years. Right? It takes 1.587 years to boost the passenger bumping rate by 1 per 100,000. That's another way you could say it. All right, now what about the y-intercept of the original function? Okay, well, let's see. The y-intercept of the original function is 0, 6.38. It's right there at the start. Okay, so 0, 6.38. There we go. Now, what does it mean? Well, that's a different story. So remember, again, I said it before, but I'll say it again. These went time, it was f, put it this way, time, rate, right? Time was your independent, rate was your dependent for the original function. So that helps you interpret it. You can say in 2000, the passenger bumping rate, hold on, I don't like that font. Or I should say I like it fine, but not for my typing. So in 2000, the passenger bumping rate was about 6.38 per 100,000. All right. Now, what about the inverse function? Well, inverse function doesn't work the same way. So it doesn't go t comma r, it goes r comma t. So it's going to be r comma t. It reverses it. All right, and it was 0 comma negative 10.127. 0 comma negative 10.127. Now, what does that mean? Well, right here. It's not 2000 anymore. That's not talking about that. It's talking about the passenger bumping rate was about 0, right? Or no passengers were being bumped. That's another way to say it. In here was 0 per 100,000 in about, oh, let's see here. If I take 2,000 and take away 10.127 just for the fun of it. Oopsie. There we go. So if I do that just for the fun of it, 2,000 take away 10.127, you'll get about 1989 and some change. So if you rounded, it'd be probably 1990. So in about 1990 when we round it. Ooh, I better write that down. 1989.873 or something like that. Okay, so you could say in the middle of 1989 or by 1990. There we go, by about 1990. Done. All right, so we've learned how to, in the other video, we learned how to find the equation by hand. Then we learned how to substitute both into the original and into the inverse and how to explain each one of those. This one we learned how to interpret the slope for the original, the slope for the inverse, the y-intercept for the original, and the y-intercept for the inverse. And I cannot stress enough, it really pays to pay attention to what your independent, what your dependent variable are for these problems. Write it out, like right here I put t comma r, or right here I put change in rate over change in time. It helps me keep track of how to interpret it. All right, now let's do it all again, but for a problem that has no story problem context. So we're going to find the inverse of f of x is equal to 2x minus 7. Hold on, I need a table. There we go. All right, step 1. We have found what y is equal to. Beautiful. Step 2. Right, so step 1 just says, hey, replace f of x with y. Literally write a different letter because it's simpler. That's all it's saying. Now step 2 is where all the big work is. You've got to solve this equation for x. So there's a couple ways you can do this, but I think the easiest thing is to get rid of the 3, because who wants 3 in the denominator anyway, right? Nobody. So we're going to multiply both sides by 3. Over here and over here. The reason you're doing that is because it'll make this fraction over here disappear. Right? So you'll be left with 3y equals 2x minus 7. All right, now you'll add 7 to both sides. 7 here, 7 over here. Now remember, these are not like terms. Oops, let me make it bigger so you can see. 3y and 7 are not like terms. So you just write 3y plus 7. There we go, equals 2x. And again, these went away because negative 7 plus 7 is 0. Then you divide both sides by 2. Do it to the left, you got to do it to the right. Oopsie, there we go. All right, now we're all done because these disappeared because 2 divided by 2 makes 1. And I'm going to flip the order just because I like it better with the x on the left. So x equals, and I'm okay with you writing this, honestly, but it's not an mx plus b form. So if you've got to write it longhand, like for my math lab, say, for your homework, then write 3/2 y plus 7/2. And nothing's stopping you from finding a decimal approximation from those if you really want to, but you know, there's not much point. All right, so that is step 2. Done. Step 3. Step 3 is you need to replace x with f inverse of y. So if I look at this bottom equation that I wrote right here, you can see, and either one of them is okay, right? Matter of fact, you know what, let me write it this way. Or, there we go, x equals, because you can write it either way, okay? All right, so if that's the case, then what I want to do is I want to replace it with f inverse of y. That's what it says to do for step 3. Oh, I should have copied that. Hold on. There we go. So watch this. Instead of writing x, I write f inverse of y. Ta-da! And of course you could do it to that one or the other one. It just depends on whichever one is the one you chose to go with. And then step 4. Now, in the story problems, we stop right there. So note, for models, we stop here, right? Linear models, story problems, like the one we did on the previous pages with the airline industry. We'd stop right there. We're done because your variables actually mean something. Back here, right here, you had t and r. You substituted f inverse of r. See, that's your y variable right there. You were done because your y variable is a rate. You can't just switch it to time because you feel like it. You have to leave it what it is. See, that's why it only has 3 steps right there. But when it doesn't have a story problem context, when it doesn't have a real life situation, then your step 4 is just to kind of rewrite the whole thing in terms of x, just because we prefer the variable x. Seriously, that's what we're doing. It's like people don't like the variable y, so let's make it x. So you write x, 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 x. Now, there's more to it than that, but not much more. Okay, and you're done. You're done with step 4. And you can box them because they're both correct, right? Either this one or this one. I think my MATLAB likes the one on the right, but they're both good. All right, now f of 4 and f inverse of 4. Now, they look very similar, but they are not the same. Letter B wants you to take 4 and put it in to the function f, which was your original function. So you're going to have to do f of 4 it was 2 times 4, I forget, minus 7 over 3, which you don't even need a calculator for. That's 8 minus 7, at least you shouldn't need a calculator for it, over 3, which is 1/3. Done. All right, what about f inverse? See the little -1? That means you're going to have to substitute it into the inverse function. So f inverse of 4. And you can put it into either one. I think the big fraction one's actually a little bit easier, but you can put it into either one. So 3 times 4 plus 7 over 2. Now remember, order of operations, you got to deal with that division bar part first. So it's 12 plus 7 over 2, which is 19 over 2. And you're done. All right. Cool. So we know how to find inverse functions. We know how to substitute into an original, substitute into an inverse, and we don't have to be told. The notation tells it for us. That's why f notation, the function notation, was so important to learn back in chapter 1. The only trick is that when it's a story problem, you don't have this extra step 4, where you switch everything back to the letter x, right? Which has some good reasons for why they do it. That's what causes the butterfly effect when you graph, right? So the butterfly effect, see how that's the letter x on both of them? It's x here in the green one and x in the blue one. That's because you can switch it and make it f inverse of x at the end. For story problems, we don't do that so much because our variables are not interchangeable. Our variables have a context, namely time and rate or time and percent or whatever. So you don't get to do that step 4. But you should still know how to be able to substitute into each one of them and explain each one of them, and then how to explain slopes and intercepts. Down here, you should be able to find this by hand, showing all the steps, and then be able to substitute into each one correctly. All right, we're done with section 5.1. I'll see you back here for logarithms. Dun, dun, dun. That's what we'll be doing the rest of this chapter. Because they're inverses. Shh, don't tell anybody. See you, bye.